So first of all, thank you very much for, I would like to thank all the organizers for the kind invitation. So, the fire that devastated Notre-Dame on April 15, 2019 marked a painful chapter in its history, but also represented an extraordinary scientific challenge, transforming the work site into a global, cross-disciplinary research hub. The restoration posed several challenges. First, researchers and professionals recovered knowledge about the cathedral's architecture and materials through the remains analysis. Modeling techniques provided insights into its physical integrity and the sensory environment. And social sciences focused on capturing the emotional connection society holds with this iconic monument. This project, coordinated by the CNRS and the Ministry of Culture in France, granted unprecedented access to materials and technical data. It brought together more than 170 researchers from over 50 research units in France, organized into 9 thematic groups: wood and frames, metal, stone and mortars, stained glass, decor, structure, acoustics, heritage immersions, and digital data. And the project progressed in parallel with the restoration, balancing urgent reconstruction with mid-term and long-term scientific goals. And most importantly, it introduced new ways of working on the same object, particularly in the digital age. So, over the past 30 years, heritage sciences have undergone a digital transformation, following 2 key trajectories. First, the digital libraries have evolved into multi-dimensional digitization by integrating multimodal and also multispectral imagery. Second, research has shifted from isolated initiative to more collaborative efforts, reflecting the complexity and the diversity of cultural heritage studies. However, this evolution, as also underlined from a previous presentation, have revealed several significant challenges for the community. First of all, a semantic gap. While digitizing cultural heritage has made great strides, much data remains fragmented and uninterpreted. How can we transform vast amount of raw data into semantically enriched insights for analysis and sharing? Second, a memory gap. Key elements of the heritage research, such as the subjective human decisions, the implicit research protocols, and individual expertise, are very difficult to capture and to preserve. So how can we memorize these essential aspects that define the real nature of our work? Third, a data correlation gap. While we can collect today multi-thematic and multidimensional data, we still lack tools for autonomously correlate this information for the integrated analysis. And finally, a technological gap. Despite advances in integrating texts, images, sounds, and 3D models into collaborative frameworks, the challenge remains to balance computational tools with the human expertise to ensure meaningful analysis. So to address these challenges, we immersed ourselves in an experimental framework that combined data production and interdisciplinary collaboration. This effort brought together a diverse community of researchers, reflecting the breadth of expertise needed for heritage science field. Our hypothesis is that the digital realm can act as a connective tissue, integrating disciplines and fostering collaboration. Our goal is to create a digital ecosystem, a socio-technical system that connects the physical features of the cathedral with the data and knowledge generated around them. So to address this challenge, we developed a 2-phase methodology. The first phase focused on producing semantically enriched data by documenting the entire process from the initial questions to data production and the creation of new knowledge. Take, for example, a team studying the nave's arch. So they begin by collecting fragments, carefully selecting and categorizing elements, analyzing their features, performing digital simulations to reconstruct the arch initial state, and finally, physically reassemble it. At every stage, we digitally trace the journey of those participants, capturing not only the data, but the reasoning, decisions, and collective insights that emerge. So by embedding a semantic layer into the data, this methodology ensures that it reflects the full depth of knowledge generated during the process. The second phase of our project is forward-looking, focused on analyzing the data produced during the research process. Take, for example, a 3D model of a beam studied for its mechanical behavior. So this model is linked to a survey drawing used for historical documentation. The same beam exists in multiple temporal states, so before and after the fire. And it includes fragments analyzed for wood dating, along with the nail studied to classify the iron composition. So this phase of our project aims to uncover the connections between material objects and objects of knowledge by identifying the intersections where disciplines converge. The digital realm enables us to bridge form, space, time, and knowledge domains by creating a comprehensive framework for understanding this relationship. So since 2019, we have been integrating a software platform designed to centralize, enrich, and specialize diverse datasets, bringing together French and international researchers in heritage digitalization. And the goal was to unify open and reusable software tools developed by various laboratories into a fully web-based platform capable of managing the entire data lifecycle, starting from the data ingestion to the 2D, 3D, and even 4D visualization and long-term preservation. And the platform also supports essential steps in semantic enrichment, such as defining metadata schemas, managing controlled vocabularies, and enabling semantic annotation in multiple dimensions. So the digital resources on our platform span a wide range of temporal states and data types related to the cathedral, and of course they continue to grow today. Initially, we gathered data from cultural institutions, laboratories, and companies with a strong support from the public authorities who recognized the importance of aligning the restoration efforts with a scientific project. And this collection includes extensive archives of photographs, surveys, drawings, and records documenting the cathedral condition. At the same time, the scientific project has generated new data on materials, structural integrity, acoustics, and even anthropological insights, enriching the global understanding of the monument. So to work with this data, we collaborate closely with data producers to define the relationship between material object, knowledge domain, and of course, the data production objectives. As shown on the screen, we organize our work in a way that goes beyond simple archiving tests or drawings. So instead, we build a corpus deeply connected to the social context that generate it. For instance, this includes restoration data such as the diagnostics provided by architects alongside scientific research on materials. And some researchers focus on medieval timber techniques, analyzing how and when wood and metal were used and preserved, while others reconstruct and date structural remains by combining archaeology, physics, chemistry, and engineering. So while certain themes address urgent restoration needs, such as structural integrity, others delve into broader questions, like the climate knowledge that can be derived from centuries-old materials. So a compelling example of this approach is the study of the timber frames. On the screen, you can see the digital reconstruction we create based on data on their state before the fire. This model integrates multiple data sources, including thousands of photographs, traditional and digital surveys, and the charred timber remains covered from the vault. But what makes this reconstruction particularly valuable is its versatility. So it provided essential information to architects working on the restoration, but also supported the woodworking group in identifying and digitizing elements stored into the reserves. Additionally, the model plays a critical role in verifying the location of these elements within the original structure, and it allows researchers to confirm or to challenge hypotheses about the remains and to accurately locate also analytical data on material. A good example of this methodology is the immersive virtual reality experience we built at the Cité de l'Architecture du Patrimoine, developed in partnership with Dassault Systèmes. So this innovative environment enables researchers to explore a life-size digital twin of the cathedral after the fire, providing a platform for the collaborative study, and in this case of the charred timber remains. And within this VR space, experts can study critical structural elements such as the actual keel by spatially locating fragments and verifying their original location within the entire cathedral framework. So let's take a closer look at the methodology. The first challenge lies in translating the material object into digital data. For us, this goes beyond creating a 3D digitization of the cathedral. It involves building a framework capable of integrating multiple scans at various scales, from detailed architectural remains to the broader urban context, and capturing this across different time periods. Additionally, we also used a cable-mounted camera system to track and to document the recovery of remains, creating a detailed four-dimensional cartographic record. And we are also digitized the state of the cathedral following its restoration, extending so the continuum of this documentation, but I cannot show you these images yet. So, a second focus of the digitization effort was the remains themselves. So to address the challenge of documenting a very large collection of elements, now approaching more than 1,000 elements, we developed a tailored solution, hardware and software solutions designed specifically for this purpose. By prototyping automated acquisition processing methods, we ensured that the resulting data is geometrically and visually homogeneous, and this is really critical because this consistency is essential for detailed comparative analysis such as examining tool marks, surface, microstructures, and decorative elements. Another critical aspect of our research has been transitioning from fragmented, heterogeneous data to multidisciplinary knowledge. By using the Aioli platform, developed in my lab since 2017, we implemented a massive 2D, 3D annotation approach to specialize scientific observation and related data. This method allowed us to organize tens of thousands of spatially structured photographs across multiple temporal states. These were grouped by thematic areas and enriched with the observation from various researchers by implementing controlled vocabularies to ensure the consistency. So one major effort involved translating the cathedral diagnostic assessment into a comprehensive 3D condition report. And this included documenting the deterioration patterns, past restorations, the stained glass analysis, and the instrumental measurement like the radar or also the stratigraphy, alongside the restoration proposals introduced by the architects. And the result is a multi-layered dataset that capture the cathedral post-fire condition. And building on this foundation, we started the integration of new 3D annotation, more than 10,000 annotation, to document the restoration and also the scientific works. For instance, we are incorporating a comprehensive repertoire of over 1,000 lapidary marks identified inside and outside the cathedral. And this is a contribution from the Stone and the Heritage Emotions Working Group. Similarly, we mapped 100 samples of medieval polychromy remains, including analysis of material layers from the Western portals, collected and studied by the Decor Working Group. In addition, we integrated the precise location of timber remains on the extract of the shore after the fire, and this includes the exact location of slices cut from each wooden element, which were studied for wood dating and for provenance through dendrochronology. And finally, we are still integrating hundreds of annotations from the metal working group, documenting elements such as the lead joints in the high windows and the staples in the gutter walls. So the example of a staple from this wall illustrates broader questions about how we connect an object's observable features to its semantic representation. For instance, the staple's location can be described using precise geometric coordinates or through specific vocabulary terms that reference several areas of the cathedral. But in parallel, the scientific analysis of the staples, such as the cuts made, the images of the cutting plane, and subsequent analytical steps must be documented and are documented in a structured way that captures the entire research process. So to achieve this, we really work closely with researchers to formalize and to document these study protocols, ensuring that the methods and data remain traceable. This brings me to the final part of my presentation, where we address how our expanding data corpus enables us to explore this intricate relationship between material objects and the knowledge they generate. So on the screen you can see a first prototype of a digital environment we are building to explore our multidisciplinary annotation corpus. This environment integrates a semantic relationship graph on the left with a dynamic 3D scene on the right, creating a new way for connecting and for explore connected data. With this prototype, we can navigate both the physical space and the cathedral and the conceptual space where observed features are linked to relevant concepts, attributes, and qualities. So to illustrate the significance of our approach, take a look at the photograph on the right of the slide. So it is linked to visual branches that represent layers of observations and interpretations applied to the same portion of physical space, just one picture. And these layers relieves dozens of concepts, descriptive attributes, vocabulary terms, and study protocols. And this example demonstrates how a single space can generate multiple analysis and interpretations, showcasing the depth and the richness of multidisciplinary research. So now imagine extending this approach to our entire data corpus, composed by hundreds of thousands of pictures, by capturing and connecting insights across the different cathedral features. A parallel challenge to the purely scientific dimension is concerning the introducing new mediation, scientific mediation approach for building narratives for the future Museum Notre-Dame, set up to open in 2027 at the Hôtel Dieu, just next to the cathedral. So we are designing strategies to connect the digital insights gained by the scientific research with the needs of diverse audiences. And The case of the Notre-Dame Oculus exemplifies this effort by digitizing and virtually reconstructing fragments recovered after 2019 fire. We captured its transformations across temporal states from its original condition to the post-fire remains and their restored form. So integrated into mixed reality environment, this data probably bridge physical and digital realms with the potential to connect the cathedral, the museum, laboratories, and also remote audiences. So I conclude with this image resembling a galaxy. It visualizes over 7,000 vocabulary terms extracted from the articles in the special issue of the Journal of Cultural Heritage we recently published. These terms cover parts of the cathedral, construction details, materials, deterioration phenomena, scientific inquiries, methodologies, instruments, and disciplines involved. So each connection in this graph reflects the unique research perspective, the unique path of each article. So this visualization highlights the challenge of navigating and mapping a vast and interconnected data and knowledge landscape focused on a single monument today, but with potential to extend to a broader field of heritage science. And while Notre-Dame will reopen its door in a few days, so December 7 and 8, our research will continue, aiming to materialize in a digital sphere this cathedral of knowledge, because beyond data organization, we are addressing the challenge of mapping the geography of scientific knowledge. This means studying how different disciplines engage with the same object and understanding how their approaches align, diverge, and intersect. I conclude this convergence of physical and digital realms to me creates a new territory, a shared space where science, culture, and public engagement meet. Thank you very much for your attention.